systems to update records and handle customer communications, reconciling failures to charge for services across billing systems by extracting information from multiple document types, and reading legal and contractual documents to extract provisions using natural language processing. RPA is the least expensive and easiest to implement of the cognitive technologies we'll discuss here, and typically brings a quick and high return on investment. It's also the least smart in the sense that these applications aren't programmed to learn and improve, though developers are slowly adding more intelligence and learning capability. It is particularly well suited to working across multiple back-end systems. At NASA, cost pressures led the agency to launch 4 RPA pilots in accounts payable and receivable, IT spending, and human resources, all managed by a shared services center. The 4 projects worked well. In the HR application, for example, 86% of transactions were completed without human intervention and are being rolled out across the organization. NASA is now implementing more RPA bots, some with higher levels of intelligence. As Jim Walker, project leader for the Shared Services Organization, notes, so far it's not rocket science. One might imagine that robotic process automation would quickly put people out of work, but across the 71 RPA projects we reviewed, 47% of the total, replacing administrative employees was neither the primary objective nor a common outcome. Only a few projects led to reductions in headcount, and in most cases, the tasks in question had already been shifted to outsourced workers. As technology improves, robotic automation projects are likely to lead to some job losses in the future, particularly in the offshore business process outsourcing industry. If you can outsource a task, you can probably automate it. Cognitive insight. The second most common type of project in our study, 38% of the total, used algorithms to detect patterns in vast volumes of data and interpret their meaning. Think of it as analytics on steroids. These machine learning applications are being used to predict what a particular customer is likely to buy, identify credit fraud in real time and detect insurance claims fraud, analyze warranty data to identify safety or quality problems in automobiles and other manufactured products, automate personalized targeting of digital ads, and provide insurers with more accurate and detailed actuarial modeling. Cognitive insights provided by machine learning differ from those available from traditional analytics in 3 ways. They are usually much more data-intensive and detailed. The models typically are trained on some part of the data set, and the models get better. That is, their ability to use new data to make predictions or put things into categories improves over time. Versions of machine learning, deep learning in particular, which attempts to mimic the activity in the human brain in order to recognize patterns, can perform feats such as recognizing images and speech. Machine learning can also make available new data for better analytics. While the activity of data curation has historically been quite labor-intensive, now machine learning can identify probabilistic matches, data that is likely to be associated with the same person or company, but that appears in slightly different formats across databases. GE has used this technology to integrate supplier data and has saved $80 million in its first year by eliminating redundancies and negotiating contracts that were previously managed at the business unit level. Similarly, a large bank used this technology to extract data on terms from supplier contracts and match it with invoice numbers, identifying tens of millions of dollars in products and services not supplied. Deloitte's audit practice is using cognitive insight to extract terms from contracts, which enables an audit to address a much higher proportion of documents, often 100%, without human auditors having to painstakingly read through them. Cognitive insight applications are typically used to improve performance on jobs only machines can do, tasks such as programmatic ad buying that involves such high-speed data crunching and automation that they've long been beyond human ability, so they're not generally a threat to